I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, IARE, Hyderabad. In this session, we are going to discuss about multitasking. We need to know some of the terminologies, that is microkernel. Kernel means it is the core component of the operating system, which provides various services like process management, managing the processes, managing the memory devices, managing the IO devices, managing the interrupts, managing the timing parameters, like that. So, these related instructions are defined in the kernel space. So, here two types of spaces are there: kernel space, user space. In user space, we are defining the user applications like VLC player, MS Office, MS browsing applications, Google Chrome browser, whatever the apps we want to install, that will be stored in the user space. All kernel services, those are stored in the kernel space. This type of storage is called monolithic kernel. Monolithic kernel. So, what is the advantage? All kernel services in the kernel space only. The limitation is, if any issue occur in the kernel space, entire OS will be stopped or not working. To overcome this limitation, we are going for microkernel. Microkernel. In microkernel, essential kernel services only installed in the kernel space. So, remaining acts like a servers. User space, we are storing the user applications. So, if any issue occur in the particular server, that server only affected without disturbing the regular works. Whatever the server having is the issue, that server only stopped. Remaining will be worked as usual. That is microkernel. Okay. Next, we will see some of the terminologies. One is process. Process means step-by-step procedure for doing particular job. Open the door, lock the wheel, open the airbag. That is some task. This process is also called task or job. The sub-process is called threads. They may use common memory space based on the requirement. Okay. Next, process states. Process means particular job. Open the door like that. Close the door. Open the airbag. So, this process are having different states. That is, whenever the process is created, that state is called create. create state. Then whenever CPU is assigned for its execution or the process ready for execution, so whenever process is created, the process enter into the created state. Once the process is ready for execution, the process enter into the ready state. Once the process is ready, when it is scheduled for execution, that process enter into the running state. While doing the execution, if the process is waiting for resources, after waiting some predefined time, still if it is not getting the resources, then process enter into the waiting state. After waiting some predefined time, again still it is not getting the resources means it enter into the blocked state. Okay. Then after getting the resources, the process again enter into the ready state. Again when it is scheduled for execution, the process enter into the running state. After completion of execution, the process enter into the completed state. So these are the various states or stages defined in the operating system. These stages are depends on the type of operating system. MS-DOS operating system states are different. VxWorks operating system, the states are different. Okay, that depends on the operating system kernel. These stages may be varies. Okay. Next, multiprocessing. Multi means more than one. Processing means executing. Means at a time we are executing multiple processes. I am playing the music, running the software simulation behind the work, download something. So at a time I am doing multiple works. That is called multiprocessing. Multi means more than one. Processing means doing the operations. So the ability to execute multiple processes simultaneously is called multiprocessing. Systems which are capable of performing multiprocessing known as multiprocessor. Core, dual core, quad core, octa core, hexa core, or core i3, core i5, like that. Multiprocessor systems. Okay. So we are executing multiple programs, switching from one to another called multiprogramming. The ability of the operating system to have multiple programs in memory which are ready for execution is referred as multiprogramming. Multitasking. Multitasking means same. Refers to the ability of the operating system to hold multiple processes in memory and switch the processor from one to another. Okay. While doing the multitasking, it involves context switching. Suppose any highest priority task is coming, we are stopping the current execution and service the latest one based on the scheduling algorithm we are using here. Either based on priority, based on less execution time, based on first in, first out, based on round robin. Like that, we may use different scheduling algorithms. At that time, we use these terminologies. Switching means changing. We are switching from present state to another state. And while switching, we can save the current task details. After completion of execution, we can retrieve the previous content, that is context retrieval. Okay. Next, there are different types of multitaskings. First one is cooperative multitasking. Cooperative means if any new process enter into the ready state, whenever the currently executing task voluntarily release the CPU, then only the new process get the CPU or new process gets serviced. That is called cooperative multitasking, cooperation between the process. Currently executing task voluntarily itself release the CPU, then only new process get the CPU. Next, preemptive multitasking. While executing the process, if any process enter into the ready state, based on the scheduling algorithm, we may service the new task, may or may not. Suppose the currently we are executing the particular task, that is priority is 2, first priority is coming into the ready state, so we are executing first priority task. If we are highest priority task, will be executing first. Our lowest priority task is executing first means we are executing currently executing task itself. Our less execution task is coming means that will be executed. So based on the scheduling algorithm, if any new process enter into the ready state, that is comparing with the currently executing task and decide which one needs to be executed currently. Okay, that is preemptive. Non-preemptive means if you are executing particular task, after completion of that task only new process get the CPU. That is non-preemptive multitasking. Okay. So in preemptive, different types of scheduling algorithms. First one is round robin. Means here each process get the equal amount of CPU time. First process executing 2 milliseconds. Second process executing 2 milliseconds. Third process executing 2 milliseconds. Like that, whatever the process are available in the ready state, ready for execution, all are executed with equal amount of time. Once completed, again that is repeated in the first in first out order. So based on the remaining execution time, remaining task will be complete. Next, shortest job first scheduling. So whatever the processes available in the ready state, among them, which process having less execution time, that is scheduled first. That is called shortest job first scheduling. Next, priority. So the processes which are available in the ready state, which one is having highest priority, that is executed first. In non-preemptive, again different types of scheduling algorithms are there. First one is first in first out. First in the sense, the process which enter into the ready state first, that is executed first. Next process which one enter, that is executed next. In the first in first out order. That is also called first come first service. Second one is last in first out. At the time of scheduling the process, which process enter into the ready state last, that process is scheduled first. That is called last in, first out. Next one is shortest job first scheduling. So, among the available process in the ready state, which process having less execution time, that is executed first, or that is scheduled for execution first. Next, priority based scheduling. The process which is having highest priority, that is executed. So in this multitasking, some of the terminologies is there. First one, CPU utilization time, means how much percentage of the CPU is being utilized by the process. As possible, we can utilize the CPU as maximum. That is best choice. Next, throughput. How many number of processes are executing in the unit amount of time? In 1 millisecond, how many processes are executed? In 1 second, how many processes are executing? 1 microsecond, how many processes are executed in that device? Like that. Next, turnaround time. The amount of time taken by the process from enter into the ready state to the completed state, including waiting time or blocked waiting time, all these things. Okay. Next, waiting time. Once the process is ready for execution, that is enter into the ready state, how much time the process is waiting for CPU to do its operation or to get CPU to do its service. That is waiting time. Next, response time, execution time itself to get the response. So among all these parameters, so if I take particular requirement, in that point of view, I will check that requirement with all the scheduling algorithms. When comparing scheduling algorithms with these parameters, which scheduling algorithm takes maximum CPU time, maximum throughput, less turnaround time because to improve the speed, less waiting time and less response time. So these should be maximum. CPU utilization should be maximum. Throughput should be maximum. Turnaround time should be minimum as possible. Waiting time should be as possible minimum. So, like based on these parameters, we can define this type of scheduling algorithm is suitable for this requirement. We will check one example. First, we are considering non-preemptive scheduling algorithm. Non-preemptive means whenever a new process enter into the ready state, it get the CPU until or after completion of currently executing task only. That is called non-preemptive. Here we are following first come first service. Okay. So read the problem. Here we are considering three processes, P1 with process IDs, P1, P2, P3 with estimated completion time 10, 5, 7 milliseconds respectively. Enter the ready queue together in the order first P1, next P2, next P3. Calculate the waiting time and turnaround time for each process and average waiting time and average turnaround time. Here including assuming there is no IO waiting. So no need to waiting for input or output resources. Okay, we will provide the solution. first. I am saying already, ready state, running state, waiting state, completed state. So at the time of 0, 3 processes enter into the ready state. In the order, first P1, next P2, next P3. At that time, the CPU schedule since it is first in, first out. So which process enter into the ready state? P1 first. So at the time of 0, P1 is scheduled for execution. Since it is non-preemptive, once completion of P1, then only new process will get the CPU. So what is the execution time for P1? 10 milliseconds. 10 milliseconds. After completion of P1, again CPU checks the ready state, or scheduler checks the ready state. So P1 is completed. P1 enter into the completed state. At the time of 10th millisecond, what are the processes available here? P2 and P3. Among which process enter into the ready state first? P2. So that is scheduled for execution. Since it is non-preemptive, after completion of P2, then only new process get the CPU. So P2 execution time is 5 milliseconds. So totally 50. So P2 enter into the running state at the time of 10th millisecond. Its execution time is 5 milliseconds. So at the time of 15th millisecond, the task is completed. Process P2 is executed. Okay. Next, at the time of 15th millisecond, P2 enter into the completed state. So what are the remaining process? P3 only. So P3 is scheduled for execution. Since it is non-preemptive, until it completes, then only new process will check. What is the execution time for P3? 7 milliseconds. Means if it is entered into the ready state, the running state at the time of 15th millisecond and completed at the time of 22 milliseconds. This is running state. Running state. Now we can calculate. So waiting time for process P1. Waiting time for process P1. So when the process P1 enter into the ready state at the time of 0. When it is scheduled for execution, 0 time itself. So how much time it is waiting in the ready state? 0 milliseconds. Next, waiting time for P2. So P2 enter into the ready state at the time of 0. But when it is scheduled for enter into the running state, 10th millisecond. So how much time it is waiting? 0 to 10 milliseconds. Total 10 milliseconds that is waiting in the ready state. Next, P3. When P3 is entered into the ready state at the time of 0. When it is scheduled for execution, means enter into the running state at the time of 15th millisecond. So how much time it is waiting in the ready state? 0 to 15 milliseconds. So waiting time for process P3 is 15 milliseconds. So what is the average waiting time? So 0 plus 10 plus 15 by 3, total 25 milliseconds by 3. That means 8.33 milliseconds. Average waiting time. Okay. Now again we are calculating the turnaround time. Turnaround time for process P1. What is the meaning of turnaround time? When the process enter into the ready state to the when the process enter into the completed state. So at the time of 0, process P1 enter into the ready state. When it is enter into the completed state, 10 milliseconds. Total 10. Next, turnaround time for process P2. So P2 enter into the ready state at the time of 0 and it is completed or it is entered into the completed state at the time of 15th millisecond. So total 0 to 15. 15 milliseconds. Next, turnaround time for process P3. So P3 enter into the ready state at the time of 0 and its execution is completed at the time of 22 milliseconds. So total time is 0 to 22 milliseconds. That is 22 milliseconds. So what is the average turnaround time? Equal to sum of these three means 7 by 3 milliseconds. That is equal to 15.67 milliseconds. So for this requirement, the average waiting time is 8.33 milliseconds. The average turnaround time is 15.67 milliseconds. So like this, we can calculate average waiting time and turnaround time and decide which scheduling algorithm is suitable for this requirement in this operating system based design. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.